Hello friends, welcome to channel Learning Support. Let us do Maths Chapter 5 Exponents. In this video we will solve question 1 to 3 of exercise 5a. Before we start solving our exercise, let us have a quick look at what are exponents and what are laws of exponents so that solving exercise becomes easier. Let's have a non-zero number a which is multiplied m times, where m is positive integer. So instead of writing this in this long form, we can write same thing in a short form or exponential form as a raised to the power m, where a is called base and m is called exponent or power or index of a. Let us now go through laws of exponents. In first law, we are multiplying two terms with common base a with different powers m and n. We can write these as common base a with powers added. That means a raised to m plus n. In second law, we are dividing two terms with common base a and different powers m and n. We can write this as a to the power m minus n on the condition if power m is greater than n. Third law is similar to second one. We have two terms with common base a and powers or index m and n. But the difference is in this case index m is less than index n. This can be written as 1 over a raised to the power n minus m. Fourth law, we have base a with two powers, one inside the bracket and one outside the bracket, one over other. In this case, base will remain same and powers are to be multiplied. That is, it will become a raised to m into n. Fifth law, we have product of two bases a and b in bracket with common power n. These can be separately written as a raised to n into b raised to n. According to sixth law, if index of any base is 0, then answer is 1. We can now start solving exercise 5a and we have to use these laws of exponents. In first question of exercise 5a, we are asked to evaluate sub-questions. Our first sub-question is 7 raised to the power 4. This index or power 4 of base 7 tells us how many times we have to multiply 7. Since it is 4, we will multiply 7 4 times. 7 into 7 into 7 into 7. 7 sevens are 49. Again 7 sevens are 49. If we multiply 49 and 49, we have answer 2401. The question is minus 5 raised to the power 3. That means minus 5 has to be multiplied 3 times. The product of minus 5 and minus 5 is plus 25, and this plus 25 and multiplied by minus 5 will give us answer minus 125. The question is 3 over 4 raised to the power 5. Power 5 or index 5 tells us that 3 over 4 has to be multiplied 5 times. Multiplying 5 3's with each other gives us 243, and multiplying 5 4's with each other gives us 1024. So our final answer is 243 upon 1024. In fourth sub question, we have minus 5 over 2 square. That means minus 5 over 2 has to be multiplied 2 times. Minus 5 multiplied by minus 5 gives us plus 25, and 2 multiplied by 2 gives us 4. So final answer is 25 upon 4. This question is done. Let us solve question 2 now. Express each of the following in exponential notation. We have two sub questions here and we have to write these in exponential notation. In first sub question, we have minus 7 upon 13 written or multiplied 3 times. So this can be written as minus 7 upon 13 raised to the power 3. We have written the question in exponential form. Just count the base term, how many times it occurs, and write that number as a power of the base term. Let us see what we can write for second question. We have minus 8 upon 3 written or multiplied 4 times. Same base is multiplied 4 times. We can write it in exponential form as minus 8 upon 3 raised to the power 4. In question 3, we are given 4 sub-questions which we have to express in exponential notation. In earlier question also we had to express in exponential notation, but there we had same base occurring 3 times or 4 times, so we could write easily. But in this case we are given numbers which occur once only. So what we have to do in this question, find prime factors of these numbers, and then we will decide how many times this number occurs and write in exponential notation. So first thing we have to do here is to find prime factors of all the numbers given here. Let us find factors of 343. 343 is divisible by 7. 343 divided by 7 gives us 49, which is again divisible by 7. Remainder 7, which is again divisible by 7. So 343 equals to 7 into 7 into 7, or we can say 343 equals to 7 cube or 7 raised to power 3. This prime factorization which we are going to do is that of 5 and 2. It is going to be a long one, but don't worry, we are going to use same prime factorization for 32, 128 and 64 also. 5 and 2 is even number, so we can start dividing it by 2. We get 256, again divisible by 2. We get 128 divisible by 2. We get 64 divided by 2. We get 32 divided by 2. We get 16 divided by 2. We get it 8. Divide again by 2, we get 4, and 2 divided by 2, we get 1. Prime factorization of 5 and 2 gives us 2 occurring 9 times. So we can write it as 2 raised to the power 9. Our first number 343 has 7 occurring 3 times, or 7 cube. What we will do, we will make some changes in factors of 5 and 2. We will make 3 groups and find a number which occurs 3 times. We can observe each group has 2 3 times. 2 2s are 4, 4 2s are 8. So we can write 5 and 2 as 8 into 8 into 8, or 8 cube. Now we can write exponential notation of first question 343 upon 5 and 2 as 7 cube upon 8 cube. Since 7 and 8 both have same index 3, we can place them in bracket and use 3 as a power or index over the bracket. Next question is minus 32 over 243. Factors of 32 we already have in 5 and 2. So this part represents factors of 32. It has 5 2's in it. Now we have to keep one important thing in mind. Numerator of question has negative sign. It is minus 32. So all its factors will also have negative sign. Number of factors will be odd. Factors of minus 32 will be minus 2 multiplied 5 times, or we can write it as minus 2 raised to 5. With odd power, minus sign will remain, and with even power, minus sign won't be there. Let us now find factors of 243. 243 is divisible by 3. 43 on division by 3 gives us 81, which is also divisible by 3, which gives us 27. Divide by 3 again gives us 9. Divide by 3 again gives us 3, and 3 divided by 3 gives us 1. We can say 243 equals to 3 multiplied 5 times, or 3 raised to 5. So now our sub question 2, minus 32 upon 243 can be in exponential form as minus 2 raised to 5 over 3 raised to 5, or it can also be written as minus 2 upon 3 raised to 5. Sub question is minus 1 upon 128. Minus 1 will not have any factors. Whatever index or power we get for 128, same we will use for minus 1 if it is odd power. Okay, now 128 also we already have in 5 and 2. So this part is 128 factorization. It has 2 occurring in it 7 times, which is odd number. So minus 1 we can write as minus 1 multiplied by minus 1 7 times, or it can be written as minus 1 raised to the power 7. Now 128 we can write as 2 multiplied 7 times, or it can also be written as 2 raised to 7. Now a sub question, minus 1 upon 128 can be expressed in exponential notation as minus 1 raised to 7 upon 2 raised to 7, or it can also be written as minus 1 upon 2 raised to 7. Fourth sub question is 729 upon 64. 64 we already have in 5 and 2. 729 we will do. It is divisible by 3. So we will start dividing 729 by 3. We get 243. Again divide by 3 we get 81. Divide by 3 we get 27. Divide by 3 we get 9. Again divide by 3 we get 3. And 3 divided by 3 is 1. Factorization of 729 has 3 occurring 6 times. So we can write 729 equals to 3 multiplied 6 times, or 3 raised to 6. Now 64. This is a prime factorization of 64. There are 6 2's in it. So we can write 64 equals to 2 multiplied 6 times, or 2 raised to the power 6. Sub question 4, 729 upon 64 can be expressed in exponential notation as 3 raised to 6 upon 2 raised to 6, or 3 upon 2 raised to 6.